This is the video for the recursive formula for arithmetic and geometric sequences. At the end of this lesson, you will be able to create the recursive formula for an arithmetic and geometric sequence. You will continue identifying arithmetic and geometric sequences and use the recursive formula to determine the next term in a given sequence. Please have your worksheet out and ready to go, where you're going to take some notes, and then we will get into the recursive formula. So there are some special notations that we are going to use with sequences for the rest of this unit, so we need to become familiar with some of these terms. This lowercase n here is going to represent a number used to describe the term number. And this will make more sense as we go over the next few symbols. This next notation here is read as a sub n. When you see this, it means that it is used to name a term in a sequence. Or we could read it as any term. Please pause the video if you need to continue copying the notes. So for example, this first bullet here, if we see this notation, a sub 6, and remember, 6 here is taking the place of the letter n, which up above we said is used to describe the term number. So a sub 6 means the sixth term. So the sixth term in any given sequence. And we're always going to use the letter A when we talk about sequences in this unit. The next one, a sub 15, is going to stand for the 15th term in a sequence. So any number that takes the place of n when it's next to the letter A, and it's written a little bit smaller at the bottom, is just going to stand for that term number. So we're going to use the sequence below to identify specific terms. So remember from class today, anytime you see a sequence, we first must come up with the pattern and see if it's arithmetic or geometric. Do you see the pattern with this one? Is it adding, multiplying? With this one, it is going up by 12. We're adding 12 each time to get to the next term. So remember, this means that this sequence is arithmetic. And remember that 12, the common difference that we are adding over and over and over again, stands for the lowercase d common difference. Going back to our notations, a sub 8 means the 8th term of the sequence. So we could say that 8 here represents a sub 1, the first term. 20 represents a sub 2, the second term of this sequence. So if we continue, this would be a sub 3, a sub 4, the fourth term, 5, 6, 7, 8. So the 8th term of this sequence is 92. Also, a sub 1, the first term of the sequence, well, that is 8 here, it's the first term, so a sub 1 equals 8. Okay, so that's some of our new notations that we are going to use for sequences. The last one that we need to be able to identify, sometimes we're going to see something that looks like this, a sub n minus 1. This notation is used to represent the previous term in a given sequence. So if we continue using the same sequence from up above, let's look at down below here. So if a sub 3 equals, well, a sub 3 is the third term, so that's 32. Then let's take a look across here. Then a sub n minus 1 equals, well, notice that 3 is taking the place of the letter n. So if I put the number 3 in place of the letter n here, I would get a sub 3 minus 1. We can do 3 minus 1, so this becomes a sub 2, which makes sense. If we're looking at the third term, then the previous term will be the second. But you can see how we get that by substituting in 3 for n. Then a sub 2, the previous term, equals 20. Let's try this with another one. a sub 7, or the 7th term. So 4, 5, 6, 7. Well, the 7th term is 80. If we know that this stands for the previous term, then we know the previous term is 68. But let's keep writing this out. So in this example, 7 took the place of n. So a sub 7 minus 1. 7 minus 1 can become a sub 6. Well, a sub 6 is the 6th term, and in this case, it's 68. So now we're going to use these notations to take a look at a certain formula. So on the back of your page, you might be wondering what it means to say the recursive formula. When you hear this phrase, it means that this formula is going to tell you how to get to the next term in a sequence as long as you know the previous term. The reason we are going to practice this formula is to get used to the notations with sequences. So, for example, we know that there are two sequences, the arithmetic and geometric sequence. For the arithmetic sequence, the recursive formula is going to be, or the way that we're going to read it, is the previous term plus d, the common difference. Which I hope makes sense. If you know the previous term, we can just add the common difference to it to get to the next term. Using our notations, the arithmetic recursive formula is going to look like this. So to get to any term in a sequence, so a sub n, we are going to use the previous term, a sub n minus 1, and then we will add d, the common difference, to it. So the geometric sequence recursive formula will be very similar. It's going to be the previous term times r, the common ratio. So the formula that you need to know is going to look like this. To get to any term in this type of sequence, we are going to take the previous term. Remember, we write that as a sub n minus 1. And this time, if we know the previous term, we are just going to multiply it by r, the common ratio, to get to the next term. So to recap, the recursive formula up here is just a fancy way of telling you how to get to the next term in a sequence as long as you know the previous term. So down below, we are going to practice using our notation and all of our symbols to write our recursive formulas and use it to get to a missing term. Determine whether each sequence is arithmetic or geometric. Then write and use the recursive formula to determine the unknown term in each sequence. So first, we must identify if it is arithmetic or geometric. In this example, don't let the fraction fool you. You can ignore it for now if you'd like, and just see, how do we get from 5 to 15 and 15 to 45? If you guessed multiplying by 3, then you are correct. Which means, looking back, 5 over 3 times 3 as a whole number would in fact give us 5. So remember that this sequence is geometric. You can abbreviate if you'd like with geo, and the common ratio is 3. Now notice here in this example, the missing term is the 1, 2, 3, 4, the 5th term of the sequence. Let's put a small a sub 5 underneath this to represent the 5th term. Now I know you already know that all we need to do is multiply 45 times 3 to get to the next term. However, our focus for today's lesson is writing the recursive formula. So what I'm going to do is use what's up above on your worksheet and use the geometric recursive formula. So, to get to any term, we will take the previous term and multiply it by r. Now I'm going to start to substitute a couple of numbers that I know. For example, I don't want to get to any term. I want to show how to get to the fifth term, which means that 5 is taking the place of n. Over here, I will continue replacing 5 with n with 5. And I also know my r, my common ratio, so I can replace that with 3. My next step, to get to the fifth term, I can do, well, 5 minus 1 is 4, so that means we're going to use the fourth term and multiply by 3. One more step, to get to the fifth term, we need to know the fourth term. Well, in this example, we do know the fourth term, it's 45. So I will replace a sub 4 with 45. Oh, sorry, 45. I was thinking of my next number. And multiply it by 3. Use your calculator if you need, and here we have the fifth term is equal to 135. So this is how you show using the recursive formula to get to the next term. Let's take a look at example 2. Take a moment and see if you can find the pattern. Are we adding or multiplying? And if you notice that we are adding negative 16 or subtracting 16, you are correct. Remember, it's okay to say subtraction when you're just identifying your pattern, but after we say that it's arithmetic, you can abbreviate here. Remember, the common difference is not 16, it's negative 16. Technically, we are adding negative 16 to each term to get to the next one. In this example, we are also missing the fifth term of the sequence, so I will label it a sub 5. Now I know that we can just take negative 93 and add negative 16 to it, but we must show using the recursive formula. So take a look up above on your worksheet and write down the recursive formula for an arithmetic sequence. Here we go. To get to any term, we will take the previous term and add d. In this example, we want to show how to get to the fifth term, so I will plug in n with 5. A sub 5 equals a sub 5 minus 1 plus d. A sub 5 equals a sub 4 plus, now I really could have replaced it up here. I didn't have to write d again because I already know that d is negative 16, which means we are adding negative 16, or if you'd like, we can just write that we are minusing 16. Remember, those two are equivalent. 2 more steps here. To get to the fifth term, we need the fourth term. Well, in this case, we know it. It is negative 93. And we are going to subtract 16. Last step. To get to the fifth term, negative 93 minus 16. You can use your calculators. Or it is negative 109. And that is how you show how to get to the fifth term using the recursive formula. At this time, there are 2 more examples for you to try. You may pause the video and try on your own, or you can follow along. So please pause now if you'd like. Example 3. Let's see if this is arithmetic or geometric. I notice over here that 4 is being added, so let me check it on the left-hand side. It's okay now that our missing number is in the middle, but we must check it somewhere else. So is negative 3 plus 4 positive 1? Yes. So now we know that our pattern is adding 4. Let's name the sequence as arithmetic and state that the common difference is 4. Now we're ready to find the missing term. In this example, we are missing the third term of this sequence. So let's write the recursive formula for an arithmetic sequence. To get to any term, we use the previous term, and add d. In this example, we specifically want to find the third term. So to get to the third term, replacing n with 3, I can also replace d at this time with positive 4. To get to the third term, 3 minus 1 is 2. We need to know the second term and add 4 to it. One more. To get to the third term, we need to know the second term. Well, in this case we do. It is 1. So 1 plus 4. Lastly, the third term is 5. And there you go. You can also put it up here now if you'd like. The last one, number 4. Let's see if this is arithmetic or geometric. Take a moment and see if you could figure it out. Notice, be on the lookout that we have here a negative, a positive. This one might be a negative, then a positive, and then a negative. We saw in class today when we see this pattern with positive, negative, and so on, we know that we must be multiplying by something that is negative. In this case, it's easiest to spot to get from here to here that we multiply by negative 2. Just going to put a little multiplication sign with that. Let's try it over here. Is 888 times negative 2 negative 1,776? It sure is. So in this case, we found our pattern. Now we can state that this is a geometric sequence, and the common r ratio is negative 2. We also want to find the third term of this sequence. So let's write our recursive formula. To get to any term, we need to know the previous term, and we will multiply it by r. Let's start to substitute. To get to the third term, so I'm plugging in 3 for n, and I know my common ratio, so I can replace it at this time, is negative 2. Please get in the habit of always putting your negative in parentheses. Let's go on. To get to the third term, this becomes a sub 2 times negative 2. One more here. To get to the third term, we know the second term, so we can replace it with 222 and show that we are multiplying by negative 2. And here you have it, the third term of the sequence, 222 times negative 2 is negative 444. So this is how you use the recursive formula, using all of your symbols and notations to show how to get to the next term in a sequence. Please write down any questions you may have and come in with this worksheet completed to class tomorrow. Thank you.